hopefully that's okay with everyone. So again, these are the three platforms. So if you wanted to run a renewable, which more and more of our customers do, natural gas, these are fully compatible. We do have gas quality requirements, which are available on our website, but we haven't seen any issues with gas quality in the United States for sure. And then for those of you that are focused also on carbon reduction, using standard natural gas, or what some will call fossil natural gas, you get about a 70% reduction. With renewables, you actually go carbon negative with many of the renewables, up to greater than 300%. And it's a little bit hard to get your head around. How do you go carbon negative? And it has to do with how we use the methane. And instead of releasing it directly into the atmosphere, where it's a really powerful climate change agent, we process it and then through the engine basically. And although CO2 is not ideal, it's better than methane, and so you actually get a negative carbon benefit. And then relative to service and warranty, it's available through our existing distributors and dealer network. So the same service level that you enjoy today through our Cummins distributors and dealer network is available and ready to service the natural gas product as well. It's a Cummins engine and service through the same tools and resources that exist today. All right, so here are the topics we're gonna cover today. So general best practice review, the maintenance schedule, which is always important, checking and changing oil, which seems like a simple event, but we found that it's really important to do that properly to get good results. Spark plugs, and then finally valve adjustments. So Jim, as the chief engineer, I know you spend a lot of time thinking about maintenance of the engines and how they can perform best in service for the customer. Could you kind of go through the things that we found to be the best practices?
Sure, Tom. Yep, thanks. Hello to all. Good morning, good afternoon. Yeah, maintenance best practices. Our engines are not, they don't love idling. So keeping idling to a minimum is always a good thing. Engines are sensitive to time-based maintenance intervals, and and that includes idle time. So if the engine's running, you're certainly using up spark plug and oil life as that engine's running, and you might be surprised at sometimes the amount of idle particular duty cycles have. And those two things, spark plugs and oil changes, they have a dramatic impact on reducing downtime and unexpected issues. I'll put a plug in for using Cummins parts. Spark plugs, filters, they've all been validated through our design standards. We don't budget, we don't test competitors or alternatives. We're always trying to raise the bar and improve the products that we offer, and it's well worth the price. Spark plugs in particular, oil in particular, they are not equivalent, across the Will-Fits and other suppliers. Something super important, we'll talk about it more later, is Cummins spec oil. 20092 is the specification at Cummins. This is actually an oil that Cummins and Valvoline developed jointly starting, I think we started the work in 2015. It took 4 years to introduce it. This came really at the fact that the American Petroleum Institute didn't have an appropriate oil for a heavy duty spark ignited engine. We recognized it. Valvoline and Cummins developed a new spec. it is significantly better than the previous spec oils that kind of aligned with existing API standards. So we'll talk about that some. Like I said, we're all about continuous improvement. Over the last couple of years, we're releasing new electronic control module calibrations about twice a year. This year, it's going to be a single major change, and maybe next year it'll be a single major change. But in 2018, 2019, 2020, we were releasing new engine calibrations for the BL index about twice a year. And in each one of those calibration releases, there's a whole bunch of enhancements and improvements. So it's well worth the time and effort to download that new calibration, at your spark plug change intervals. And then finally, low pressure fuel filters. If you've got them on your vehicle, make sure you're draining them on a regular basis. Get the junk out of there.
Hey, Jim, on the ECM calibration, how does that occur? What are the tools that are needed to update the ECM?
I'm certainly not a Cummins maintenance expert, but I think it's an inline module and access to the calibration that's released to QuickServe Online, right?
Yeah, so it's using the same tools as the diesel versions. Right. So it's Insight, it's the inline adapter, it's all those same tools that if a fleet has invested in the software, they can update the natural gas just as easily as they can do the diesel. I also, just on the fuel low pressure fuel filters, you can see the petcocks at the bottom there are circled. To drain them, it's super easy. The biggest challenge is getting the hood tilted and reaching in there. You just loosen those. You'll hear a little bit of gas that will come out, and if it spits any any gunk, basically it probably is lube oil from the compressor, from the fuel compressor. So it's actually, not only does it protect the engine, but it's a good tattletale to know whether or not your compressor is passing a lot of oil. A little bit of oil is no big deal. If you're collecting a lot, you probably want to contact your fuel provider. All right, so with that, let's jump into the schedule itself. This is a total eye chart, and for folks that have joined, I'm recording this presentation. We will post it, so you'll have this material available to you. I'll send the link to all the folks that registered for the webinar today, so you don't need to try to capture it all. But Jim, maybe you could talk to some of the footnotes in particular, because those are, it's very straightforward in terms of the cycle, but we do have a few footnotes that probably warrant some more explanation.
Sure. Yeah, so on the oil filters, or the oil change intervals and filters, they got a footnote there on the ISLG and the L9N. It's 1,000 hours for products that are using the new CES 20092 spec oil, and we'll have a list of suppliers later that supply that oil. The footnote denotes the new oil that Valvoline released last year. It's called Valvoline One Solution Gen 2, where we're allowing up to 1,500 hours between change intervals for the L9N with that oil. So that's a pretty big deal to a lot of customers. And like I said, the result of a next generation of work. We did work with Valvoline starting in 2015 on the new spec. And then almost immediately we started working on a a higher level product. And primarily it was around extending the oil's ability to manage oxidation. And so the oxidation resistance on this One Solution Gen 2 oil is head and shoulders even above the 20092 standard spec. And that's what gets you an extra 500 hours on your change interval. So that's one footnote. Spark plugs, really important to these engines. You'll see a footnote against the ISX12N, ISX12G, 1,000 hours. You know, that's guidance, right? Depends on your duty cycle. And we certainly have customers with higher duty cycles, you know, more load, you know, more regularly. And, you know, you're going to chew up your spark plugs faster. And, you know, where we've done some work is we've measured duty cycle using the ECM and the data it's recording. And we draw a line around 35%. So that'd be 35% of full load all the time. And when you're above that level, you're probably looking at a plug change interval that's 750 hours as opposed to 1,000 hours. In a like way, if you have relatively flat roads and light loads, you might go beyond 1,000 hours. But 1,000 hours is a general recommendation. It could go lower to 750 depending on the duty cycle. And then finally, we've got a new crankcase breather that we just introduced on the L9N product for model year 2021. So you see there, it's a 2,000 hour crankcase breather filter change for all the product through 2020. But with the model year 2021 product, the L9N, we have a non-serviceable on-engine crankcase, closed crankcase breather system. And no maintenance. It's a significant improvement over the old design. So that's a kind of a late breaking improvement that we've just added.
Awesome, Jim. Yeah. Awesome, Jim. So we had a couple of questions come in. One question is, are low pressure fuel filters recommended? They come standard on the B series and the L series. Mm-hmm. They're an option on the X series.
On the X, that's right. And so let me say a couple words about that. In 2018, when we launched the new ISX12N, it went out with a new fuel system design that is more tolerant to the finer debris, and hence the lack of a requirement for a low pressure filter on the ISX12N product after 2018. The ISLG, the L9N, the 6.7 product, still using the older style fuel system, a little more sensitive to that debris. Like we had mentioned, drain those filters. We've got a gas mass flow sensor at the entry of the fuel mixing system, and that can become contaminated with compressor oil. And when that does, it will misread. And with the diagnostics that we have on the engine, we'll detect a problem in those readings, and we'll light a light. So yeah, definitely want to drain those filters and stay on top of them.
Yeah. So my personal philosophy is more filtration is better. It certainly can't hurt. Yeah. You've got. You do have, you need to drain them if you choose to get them on the 12-liter product, and then you have to service them. So there's a little bit of labor and cost associated with that. But again, I'm sort of a big fan of filtration, because if you do get some gunk in the system, it'll catch it and prevent any downstream issues. So I guess that's a recommendation if you're if you're looking for one. I'm always a big fan of more filtration. Okay, so then the next question, and Jim, I don't know if you're going to know the answer to this, and I'm not sure. So we may have to circle back and answer this one. But the question is, are you able to update the ECM calibration with Insight Light? And I don't think so, but I need to confirm that. I don't know, Jim, if you know.
I don't know, Tom.
Okay. All right. So we'll Pat, we'll have to circle back on that one and get you an answer, because I don't know the answer to that one. Okay. And then Fritz is asking, it's a bit of a comment and an ask, which is, oh, okay. So Dustin weighed in on the ECM calibration. He says a pro license is required to do ECM calibration. So there you go. The Insight Light will not work. So we got that one answered. Thank you, Dustin, for weighing in with that. So Fritz was asking, basically, many repair parts are, that used to be easily sourced are now difficult with the chip shortage, and then we're seeing other things like water pumps and cylinder heads and fuel control valves. He's asking basically, does Cummins have any updates on parts availability by the chip shortage, and then I suspect other parts, and is there a workaround? So yeah, so this is an industry challenge. It's something we're struggling with every day. The workarounds are tough in the sense that if we don't have the parts, we kind of don't have the parts. We've got a whole team of folks that are, and I wouldn't want to be one of them right now. They are, they're trying their darndest to get service parts into inventory and then get them out to customers as they need them. It seems like as soon as we resolve one part, another one pops up that's a shortage, and then they're off chasing that one with our suppliers. So I wish I had a better answer. We're doing the best we can to keep the engines, the time out of service to a minimum. In some cases, though, it does get extended, and we're trying to fill the orders as soon as we can. So I know that's probably not a great answer, but that's kind of where we are right now. And part of what we struggle with is our suppliers are all over the U.S. and frankly all over the world. And so when you get COVID spikes and there's a lockdown, even if the U.S. seems like it's in pretty good shape, if it's a country that we're sourcing a part from, they may close down that plant, and next thing you know, we're short parts again. So it is definitely a tough deal right now. Okay, all right, I don't see any more questions at the moment, so we'll move to the next. All right, so Jim, checking and draining oil. I mean, we've been doing this really since the advent of the engines, right?
Sounds simple.
Sounds simple. It is a little more, well, it's not complicated, but there is a process. Yeah, yeah. So maybe you could sort of walk us through the process, and then a watch out on the 12N in particular.
Yeah, and yeah, full disclosure. Yeah, it is kind of nuanced. It's maybe not as simple as it might appear, at least particularly with the ISX 12N engine. We're always looking at ways of improving the customer experience, extending service intervals, protecting the engine to greater degrees, ensuring long-term durability. And in the case of the 12N, it led to what was thought to be a clever idea. It still is a clever idea, where when the engine's running, you're storing a couple quarts of oil up in the cylinder head. And what that means is that we can run a higher capacity oil pan, if you will, when the engine's running, and we don't have fear of whipping it into a foam with the crankshaft or connecting rods. So it was a means of extending intervals, making the engine more durable. However, it does come at the inconvenience of having to wait a period of time. 15 minutes is a good recommendation after the engine shut down before you check the oil, to allow that oil to drain down into the pan. And it's critical, because what we've seen is customers maybe accustomed to checking oil immediately after the engine is shut down. It'll measure a few quarts low and they'll add oil. That in turn, that oil will get churned up by the crankshaft and connecting rods and exacerbate any kind of oil consumption and accelerate it, which then you'll add more oil at the next time you shut down and check the oil very quickly. So the advice here is that you wait the 15 minutes. You only add oil when it is at the add mark, right? There's 4 quarts of oil between that full mark and the add mark. So if it's somewhere in between, it's not a big deal. Engine still has plenty of protection. And we just suggest that you add oil when it's at the add mark, and to avoid that overfilling condition. The second thing that you particularly have to be wary of on the 12 liter is that you've got dual oil sumps, and both need to be drained to get the best performance out of the oil in there. So you've got the large traditional sump, everyone's probably familiar with that, but then you've got a smaller sump that needs to be drained as well. And you can see the reference down there before. So that's it's a subtlety. A lot of customers don't understand that. Again, working with the OEMs, we're always constrained around how much space there is for the oil pan, and then you get the competing priorities of extending drain intervals and longer life engines. So we come up with this dual sump arrangement, but it does require a little extra effort to drain that second sump.
Yeah, that's great. One of the things that, and again, it's always a challenge to get the drivers to do their walk around, let alone sort of do it in the order you'd like them to do. And the recommendation, which isn't necessarily the way they sort of want to do it. I mean, my observation is they want to get in the cab, they want to turn it on, build air, get the heating or cooling going, and all that kind of stuff. Shut it off real quick, check the oil, right? Then it'll show low. So really, what we recommend is check the oil before you fire up the engine in the morning. Then you'll get a nice clean read. And if you need to add, then add, but if it's within the hash marks, just leave it be. Don't add till you get to the bottom. I'll also note that, and I think that in particular, it's the Valvoline product, which we're going to talk about in more detail next, is as the additive package breaks down, the oil actually can turn red, which is a bit disturbing if you're not expecting to see red oil, especially on a natural gas engine. Of course, on the diesels it turns black basically immediately, but that's totally normal for it to change color. It just means the additive package is doing its job and is in the process of protecting the engine.
Yeah, no soot to make the oil black.
Right. Yeah, no soot. Exactly. Okay, so let's, Jim, you had mentioned that there was a lot of work that was done around, getting a better oil into these engines and extending the oil drains, and we've done that work with Valvoline, and so maybe you can spend a minute on the oil specification and all the alternatives that are also available if you don't want to go with the Valvoline option.
Yeah, sure. Like I said, we started developing this new oil specification about 2015. I think it was launched, maybe it was mid 2018 when it launched into the marketplace. The many oil manufacturers, you can see them all listed there, they've kind of followed suit, and they're offering oils that meet this new Cummins specification. Like I said, the Gen 2 product that Valvoline's just come out with here recently within the last year takes that up another notch. It still meets obviously all of 20,092 requirements, but it's exceeding them by a fair bit. And like I said, it's primarily around oxidation resistance. And we'll get into it with the pistons, but that's the bugaboo here, right? You've got calorie cooled pistons. Oxidation resistance is critical to these engines and keeping those pistons healthy. And this formulation of oil is far superior to the previous requirements that we had. And like I said, this is a Cummins derived spec. We didn't have the benefit of the American Petroleum Institute to test and define an oil specification for a heavy duty spark ignited engine. We did that ourselves. And you can see all the manufacturers now that are offering competitive products.
Yeah, it you know, to the point about how much better it is, it allowed us to immediately double the oil change interval.
That's right. I forgot to mention that.
Yeah, and on the 9 liter, we actually tripled the oil change interval. So it is markedly better. The other really cool thing about this oil is it's compatible with diesel engines and then all the spark ignited. So if you were running gasoline engines in your fleet as well, I mean, that's why they called it one solution. You can use this one product across, you know, all your engines. So it just reduces, you know, inventory and confusion and risk of putting the wrong oil in the wrong engine. So it really is a nice option.
Yeah, it meets the latest API spec for diesel engines. And forgive me, I forget what that is. I've been in spark ignited too long.
Too long, yeah. But if you're interested, certainly, you know, Cummins does carry, you know, the Valvoline product. It's likely that whoever you're getting your lubricants from now probably carry it, but I don't, you know, there's all sorts of relationships on who carries what, but certainly you could reach out to us or Valvoline directly. All right, so let's jump into spark plugs, which again, you know, for folks, you know, that have been driving cars for 100 years, not that any of us are that old, because Jim and I are still very young men. You know, it seems like, you know, so simple, and you go down to the auto parts store and grab a few, and they're 50 cents a piece. But boy, the technology has changed, you know, over time. Maybe you could, you know, speak to, you know, sort of how we, you know, the reasons behind, you know, the critical nature of using the right spark plugs.
As all of our existing customers know, this is not a 50-cent spark plug. These are platinum alloyed spark plugs. They're pretty expensive, but they have to withstand just an incredible environment in the combustion chamber in terms of heat. There's extensive testing on spark plugs and selecting the plug that we do. It's not like the old days where, you know, you might double check the gap on the plugs. I can assure you that the plugs that are coming out of Denso, that's our supplier, that gap is within 1/1000th of an inch, plus or minus 1/1000th. You're not going to do that by hand certainly on a consistent basis. Plugs come with gap protectors. There should be no reason to touch them. We're real particular about the plugs. Anytime we're making a change in the plug, we have to go through and we have to recertify emissions compliance with any kind of change that we make to the plug. And you know, obviously I can't say if the will fit plugs will or will not meet the emissions requirements of this engine. But I can tell you that there's a lot of subtleties in the spark plug design and how it interacts with our engine design. So it's pretty important that you use the factory plugs. And frankly, you're going to get the best life out of the plug from the factory plug. I think that's pretty certain. Yeah, so it's just, yeah, be careful with them, handle them carefully. You know,
Maybe just, yeah,
tools in
maybe
the
just,
shop so the plug doesn't drop into the cylinder head from, 6 or 8 inches above and close that gap. Yep.
yeah, and maybe just a couple other comments. Even if you're tempted to check that gap, if you just have to use a pin gauge, using any of those friction gauges, you're actually, what you're going to do is you're going to scrape off some of that precious metal, and you're going to reduce the life of the plug. So, like Jim said, if they come pre-gapped, if they don't look right, return it for a replacement.
Yeah.
We would rather have you do that. We've heard lots and lots of stories about folks that have gone the aftermarket plug route, and what we found is they flat don't have the life of the spec that we provide, and then that's our spec. So if somebody shows up and says, well, I can get you a plug that's the equivalent spec, that's a patented, it's proprietary specification. So getting the spark plugs really makes a huge difference. Partly because you don't want to get that misfire, because there's other issues with that, but probably more importantly is it gets you out of your service cycle, right? You've got now to bring a truck in and do a service and a maintenance that's off cycle, and that's way more expensive than the incremental cost for the spark plugs.
Yeah, and then additionally, Tom, if those plugs are at their life's end, you're stressing the ignition coil as well, right? And then you're driving wear and tear into that ignition coil because of the high spark voltages that are just going to accelerate any issues that you have with the ignition coil. So it's good insurance, and keep it on the schedule. Watch it closely.
Yeah, good comments. All right. So the other one that was on the maintenance schedule that makes a big difference is the valve adjustments. Jim, maybe you can sort of get into why we're so concerned or focus maybe on keeping the valves adjusted per the maintenance schedule.
Yeah, it's a tricky situation here, right? I mean, without properly adjusted valves, you are subject to misfire. And that can lead to all sorts of bad things happening, including valve damage, power cylinder damage. It's essential that you just stay on top of this. Yeah, it's just part of the deal.
Yeah, and so on, the initial valve sets at 1,000 hours, and then we've got subsequent that are a little bit longer. One of the so the 1,000-hour one, the initial set is in particular really critical. They're all critical,
Yep.
but that one is particular critical.
Yeah, because you see a lot of run-in kind of gap change in that first 1,000 hours that you want to take up quickly, and then depending on the engine, it's 2,000 or 3,000 hours thereafter.
Yeah, and one of the questions we get a lot is, well, so how many hours do we or how many miles does is 1,000 hours? And it comes down to your average vehicle speed. And so if you want to think about it in miles, what we do is run your normal routes for a while, a couple months, right? And then you can take data off of the ECM, use the Insight tool to do that, and it'll give you your average speed, and then basically you multiply it by 1,000, and there you go. But one of the things that, and this is the case with the spark plugs as well, is when you're idling, we're still using up that plug. We're still putting some slop into the valves that need to be adjusted. So we're really focused on hours and not so much miles. We can convert it, into miles if that's easier for you. Most OEMs now on the dash, if you hit the right combination of buttons, it'll give you the engine hours. And so we really, really want you to focus on engine hours versus mileages on the odometer. Okay, so we've got a couple of questions here that came in. So when adjusting the valves, do we use the Cummins 6-inch-pound adjusting tool on CNG engines? So I'm not familiar with the 6-inch-pound adjusting tool. Are you, Jim?
I am not. I was just thinking I need Jason Bauer.
Yeah, Jason is our resident expert on these kinds of things. So I'm gonna leave that. And if I know there are some other Cummins folks that are on, if anybody knows the answer and wants to weigh in via chat, please do. Otherwise, we'll have to take that one as homework for us. The next question is, can you speak to how ambient temperature may increase or decrease fuel capacity and any impacts that might have on miles per gallon? So fuel capacity. So I'll give it a go. I think there might have been some fuel tank folks on the call. If somebody is there and wants to raise their hand or put it in the chat, I can allow to talk and answer that. In general, though, the refueling facilities adjust for the ambient temperature so that you get a full fill. And so basically, if you're in a hot ambient, gas expands, right, in hot environments. Plus you add some heat to the gas as you compress it. And so what they'll do is and this is in quotes, they'll overpressurize in the sense that once everything sort of settles back down to the right temperature, you've got a full fill. And so it compensates basically for the temperature. Unless Jim, you're going to correct me. I don't, temperature doesn't have any impact on the efficiency of the engine.
No, not in a measurable way. No.
Yeah. So that and then since this kind of came up, one of the things that we found in really cold climates is, some fleets will, on their diesel engines, they'll let them run all night so they don't gel up. Since we're dealing with a gas, you don't have to let them run all night. You still got to plug them in to keep the oil warm, right? So the block heater is important. But in fact, we recommend you don't run them all night. We don't have fuel gelling issues and those sorts of things. So we don't have the same challenge in the cold weather environments that diesel does. And it looks like the question on the valve adjustments got answered. So thank you for those that weighed in. And I'll also see somebody weighed in on the temperature compensation of the fuel. So let's see, I think another question that came in, can you tell me what the SRT is for running the overheads and spark plug replacements? Yeah, the standard repair time. I don't know that off the top of my head. So again, I'm going to ask for support from the audience. And if not, Gregory, I will get that for you. I don't know. I don't think there's nothing trick about it. Relative to a diesel engine. But I don't know what the SRT is. Let's see. How cold should the engine be for the valve adjustment? Well, it basically should be parked overnight. That's, yeah. I'll tell you a funny side story. I had a customer once that said they wanted to come in and get their valves adjusted, and I said, okay, well, bring it in and we'll do it in the morning. And he says, no, I need it done this afternoon. I said, well, I got to do it cold. And he says, well, I'm not driving that far. And I said, sir, those engines get hot fast. Yeah, it's best to wait overnight and let it be at ambient. Okay, so let's see. Another question that came in. So in a vocational application, it runs a PTO with high idle hours. Does this incrementally decrease the engine hour service cycle? No. So if you're,
oh, go ahead, Tom.
yeah, so no, it's as long as you're working on an hour basis, and that's why we emphasize don't use miles. So if you're running, especially right, if you're running a PTO or you've got high idle, the hours always count. And so if you stick to that hour schedule, you're going to be in great shape. Anything else on that, Jim? That
the engineer in me, we treat PTO hours differently than idle hours, right? Because you generally got some significant load on the engine when you're running that PTO, and the engine's happier doing that than just idling with no load.
That's true. Yep. Okay. All right. So, so there was one more that came in. Are these engines still up to $50,000 more than a diesel engine? So the incremental cost is primarily associated with the fuel tanks and that package. So depending on the fuel tank size that you want to run, which is really a function of range, it's going to be probably anywhere from 30 to 50,000 incremental. So it's, the engine itself is, isn't the, the driving force behind the incremental cost, but yeah, they still have an incremental cost. Okay, so I think we've gotten down to the bottom of the questions that have come in so far. All right, Jim, so this is always the fun one. So if we're late on maintenance, what are all the awful things that can happen?
Yeah. So this is what we spend a lot of time working on and trying to assess and analyze. But we've got a couple categories, top hit list for us. Misfire is top of the list. Like we'd mentioned, run your plugs too long. It in turn will stress the ignition coils. It in turn is going to result in all sorts of not so pleasant things. Fault lamps is the least of your worries. You're going to have the rough running and the low power complaints. But, we can also trace misfire to catalyst damage, right? If you've got unburned fuel going into your three-way catalyst due to misfire, we see damage to the substrate, and that over time can drive premature replacement of the catalyst. Catalyst should last the useful life of the engine, right? That's how it's designed. If the engine's misfiring, it doesn't. I mentioned the ignition coils and running beyond extended life or beyond end of life. We've also got the extensions, right, that attach to the coils and reach down to the plugs. Those become stressed as well, and with the higher spark plug voltages that they're being asked to conduct, and that'll lead to premature damage. Those last two categories, front and rear main seal leaks and piston failures, we trace a lot of this to oil, and particularly I mentioned before, the oil degrading because of basically it becomes goes back to carbon, becomes carbonaceous with the oxidation of the oil, the burning of the oil, if you will. In the case of our front and rear main seal leaks, You know, we've got these pumping elements that are almost a spiral groove in the seal itself, and that's what pumps oil back into the oil pan. And what we see is when the oil has gone beyond its end of life, and you're getting a lot of that oxidation and a lot of that carbonaceous material, it's clogging those channels, those spiral channels that pump the oil back into the pan. And if it can't go back into the pan, it goes out the front or rear seal. So it's essential. It's really important to stay on top of this. Piston failures, I mentioned that. These are what we call gallery cooled pistons. So, you know, imagine a cavity. It's about as big around as my finger that is around, or it's underneath the piston bowl. And, you know, you've got piston cooling nozzles. We're injecting oil up into that gallery as the engine is running. That oil is circulating. It's evacuating heat from the piston. When you run your oil past its end of life, it is subject to a buildup in this gallery, right? And as that oil buildup gets thicker and thicker, the piston top is almost insulated then from conducting that heat down to the oil and getting it out of there. And that is what's going to lead to some catastrophic piston failures. So we see that quite a bit. It's not unusual to have, you know, we're talking about something on the order of a 0.5 millimeter thickness of coked oil, and the piston temperatures just go through the roof at that point, and you're going to have a fatigue crack. So these are I think the most typical kind of symptoms that we see of late or poor or inconsistent maintenance.
Yeah, and it's not to drive fear. It's just to share knowledge and best practice. And what we found is, and this gets to one of the questions that came in around anticipated engine life. If you're following the maintenance schedule, we've seen these engines run 1 million miles or more before rebuild, it really is critical to use all those tools and the right parts, to make it work. Folks have said, well, you're just trying to sell us parts, and we're constantly trying to extend the service intervals, but within the boundaries of we don't want to push them so far that it ends up in a problem with the engine or a failure, worse yet. So we're trying to balance between those two. So if you're following the maintenance schedule, you really should see diesel-like lifetime. So and Keith had asked this, part of the challenge in answering that question is every application is different. If a cement mixer with a 9-liter engine, has a very different life than a 12-liter that's running a steady state on a highway. So, there's no one size fits all answer, unfortunately. If you find yourself with questions or concerns, or, around your particular situation, reach out to your Cummins account executive. They're there to help, and they can bring in additional resources, like myself or Jim or his team, depending on how deep you want to go. Let's see. So I got a couple more that came back in here. So hopefully that answered the question, Keith. So Rick is asking, is there a maximum number of fault counts in Cummins Insight that can be logged per code? While troubleshooting on an ISL. Well, yeah. So Rick, that's a level of detail that I don't know. That's a lot of fault counts. He says it stopped at 1,199. Let us get back to you on that one. I think that's going to need some support that we don't have on this call. So I will capture that one. And then the presentation. So yes, the presentation, we will make the presentation available along with the video recording after, and what I'll do is I'll send the link to everyone that's registered. And this is all, these are all public slides, so you're welcome to use them in class. Somebody wanted to use them in class, so we'll get those out to you. And then see, going back to the valve adjustment, how severe is it to go past the hours on a valve adjustment if the engine is run 8 hours at full performance? So Carlos, you asked this. I'm not sure. I didn't understand it, Jim. Did you maybe capture what he was getting after?
Yeah, I'm not entirely.
Right.
So of whether the valve adjustment interval would be different for a different duty cycle.
Yeah, maybe. Carlos, we got two options. You can either try to clarify in the chat, or if you want, I could unmute you and you could ask it directly. So maybe you could put that in the chat on which way you'd like to go. And in the meantime, we got another one from Keith. Keith asking some really good questions today. How would you convert 1 million miles to hours? Yeah, so that is going to depend on the engine speed, or the vehicle speed. So it's unfortunately, I mean, the math is straightforward enough, but the challenge is knowing what the average vehicle speed is for the application that it's in, because we see average vehicle speeds all over the place, even within fleets. I'll also sort of note that most folks overestimate their vehicle speed. When you ask them what's your average vehicle speed, a lot of them will talk about their cruise speed. So, well, I go 55 miles an hour, I go 60 miles an hour, which is absolutely true when you're out on the highway. But when you factor in all of the around town and all the idle, it drops fast. It's not untypical to see even trucks that do a fair amount over the road to have an average vehicle speed of 30 to 35 miles an hour.
I was going to say 35 miles an hour, Tom, I think is kind of the upper end of what we see.
Yeah. So, so don't assume, right? Get the data. The ECM's got it, and you can extract it. And if you don't have the tools, again, reach out to your account executive and they can get that for you.
Yeah. So, 1 million miles at 35 miles an hour, that's roughly 30,000 hours.
Yeah.
Right. Yeah.
So hopefully that helps, Keith. I think maybe that's another way to look at it, is to look at it that way. All right. So Rick, I owe you an answer on the fault, so I'll capture that. Okay. So our last slide, I'm going to bring in Hugh Donnell. If you want, I'm actually going to stop recording now.